The concept of time travel is often explored in science fiction, but according to our current understanding of physics, there is no known way to travel back in time. The laws of physics, as we currently understand them, do not allow for time travel in the traditional sense, where a person could go back in time and change events that have already occurred. One potential way to travel through time is through time dilation, which is a consequence of Einstein's theory of relativity. Time dilation occurs when an object travels at very high speeds or experiences intense gravitational fields. However, this type of time travel only allows for a difference in the passage of time between two objects or locations, rather than actual movement through time. Let's take an example of time dilation in simple terms. Imagine you have a friend who is an astronaut, and they are traveling in a spaceship at a speed close to the speed of light. While they are traveling, they have a clock that is ticking away just like any other clock. However, from your perspective on Earth, you observe that their clock is ticking slower than a clock on Earth. This means that time is passing more slowly for your friend in the spaceship relative to you on Earth. Now, let's say your friend spends a year traveling in the spaceship and then returns to Earth. According to their clock, only 1 year has passed. However, according to the clocks on Earth, several years may have passed, depending on how fast the spaceship was traveling. This effect is time dilation. You can see this in movies like Interstellar. Similarly, if one clock is placed near a massive object such as a black hole, where the gravitational field is very strong, time will appear to run slower for that clock than for a clock located in a weaker gravitational field. This means that if one clock is taken closer to a massive object and then returned to a location with weaker gravity, it will show less time has passed than a clock that remained in the weaker gravitational field. The effect of time dilation has been observed experimentally and is crucial for many modern technologies, such as GPS systems, which rely on precise timing measurements. Without the corrections for time dilation, GPS systems would be significantly less accurate. There are also theoretical concepts like wormholes and closed time-like curves that have been proposed as possible ways to travel through time. However, these ideas are purely speculative and are not supported by any experimental evidence. In summary, while time travel remains a popular concept in science fiction, there is currently no scientific evidence to suggest that it is possible in the way that it is often portrayed. If you think about traveling at high speed, or at the speed of light, it is currently impossible, as doing so would require an infinite amount of energy.